Okay, we're going to talk about the quotient rule. So this is the second of the exponent rules. And we are going to, again, leave a little space here, leave maybe 3 lines. We're going to come back and we're going to look to see if we can come up with the rule ourselves as we're looking at some of the examples. All right, so let's do example 1. And I'm going to use x to the 5th power divided by x to the 3rd power. Now I'm going to expand the first few of these examples into expanded form so that you can see how we cancel them out. And then after that, we're just going to use the rule. So x to the 5th would be 1, 2, 3, 4, 5. And I'm going to divide that by how many here? 3. 1, 2, 3. So we can simplify by canceling out, almost like by dividing by a certain number like we do with our fractions to simplify. So here, these would cancel each other out and make 1. Those would cancel each other out and make 1. And these would cancel each other out and make 1. How many do I have left? X to the 2nd power. X, I have 2 left. Now go back and look. We have x to the 5th, x to the 3rd, and our answer is x to the 2nd power. Let's try another one. We have x to the 6th over x squared. Again, 1, 2, 3, 4, 5, 6 over 2. 1, 2. So x divided by x is going to give me 1. They cancel each out. X divided by x would give me 1. They cancel each other out. How many x's do I have left? 1, 2, 3, 4. So I started with x to the 6th divided by x to the 2nd, and I came up with x to the 4th. If I have 7 to the 5th power over 7 to the 4th power, so 1, 2, 3, 4, 5, divided by 4 of them, 1, 2, 3, 4. So 7 divided by 7 is 1, 1, 1, 1. How many do I have left? 7 to the 1st power, which is what you would write because you have 1 left, but we know that that 1 is always understood and we never record it, so that would be 7. So have you seen or developed a pattern here? 7 to the 5th divided by 7 to the 4th, and I have 1 left. So hopefully you have seen that when you divide by the same base, again, it has to be the same base, you subtract. The exponents. Okay, so I put that in squares. So subtract the exponents. All right, so that would have been 5 minus 3 would have given me 2. 6 minus 2 would have given me 4. 5 minus 4 would have given me 7. You are not subtracting the base. You are only subtracting the exponents. So you're not going to say 7 minus 7 is 0. This would be 0. No. You're only subtracting the exponents. All right, so let's try this one. 20, x to the 5th, y to the 9th, divided by 5, x to the negative 3, y to the 4th. Now this is when it becomes very, very important that you write it out. When you write it out. Okay, so we know that 20 divided by 5 gives me 4. Okay, now I'm going to take that x, and x is going to be 5. You're dividing x to the 5th divided by x to the negative 3. When we're dividing by the same base, we are going to subtract those exponents. So I'm going to write it up here. 5 minus negative 3. That becomes 5 plus positive 3. Remember, x, you know how to use your integers. Then this is going to be y to the 9th divided by y to the 4th means 9 minus 4. So my answer is going to be 4x, what's 5 plus 3 is 8, to the y, 9 minus 4 is 5. All right. If I have 3 to the 4th, and I'm dividing 3 to the 10th. Remember, we are not subtracting the base. We are only subtracting the exponent. So this would actually be 3 to the 4 minus 10. 4 minus 10. That becomes plus negative 10. So that's going to be 3 to the negative 6th power. We cannot have anything to the negative power, so we have to change that to 1 over 3 to the 6th. All right, I'm going to do one more, and it's probably going to be a little tricky, so let's see if we can follow along. And if you do, great. If not, I'm going to go over it in class today anyway. All right, so we're going to have 6 squared y to the 3rd divided by 5x to the 8th y to the 7th. All right, 6 divided by 5. You can't really do that. So I'm just going to go over and I'm just going to leave the 6 where it is, and I'm going to leave the 5 where it is. I don't want a decimal. I want it to be left in fraction form, no decimal. So now I'm going to take x, and it's going to be 2 minus 8. Then I'm going to take y, and it's going to be 3 minus 7. So that means I'm going to have 6 over 5. X is now going to be 2 plus negative 8, which is negative 6. And y would be 3 plus negative 7, which is negative 4. Now I have negative exponents. As soon as I see negative exponents, I know I've got to get rid of them. So I'm going to rewrite this as 6 over 5, because my 6 and 5 don't have any negative exponents. They're just 1s, remember? Automatically understood to be a 1. But my negative 6 exponent here with the x, that has to be moved to the denominator. And the y to the negative 4, that can't stay, so that has to also be moved to the denominator. So my final answer is going to be 6 over 5, x to the 6th power, y to the 4th. Now we're going to talk about this more in class, but I want you to have the notes ahead of time so you can kind of take a peek at them.